Now here's a problem where they actually gave us the raw data. We've got 1, 2, 3, 4, 5, 6, 7, and a 7. It says a food safety guideline is that the mercury in fish should be below 1 part per million. Listed below are the amounts of mercury found in tuna sushi sampled at different stores in a major city. Construct a 95% confidence interval estimate of the mean amount of mercury in the population. Does it appear there is too much mercury in tuna sushi? Okay, let's go ahead and load this into StatCrunch. In this case, they have given us the raw data. We still want a confidence interval, so we're going to go to, is this Z or T? It's definitely not a proportion. What determines whether it's Z or T? Have they given us the population standard deviation? No. What size sample have we got? Very small. Now, they did not state that this is normally distributed. They didn't say anything about that. I guess we can assume that it would probably be normally distributed. So let's go with T, one sample with data. We have to select the column where the data is located. There's only one column. Let's see, 95% confidence interval. Make sure I check that. Compute. Now they can figure out that the degrees of freedom is 6 because the computer can subtract 1. We know the sample mean. We know the lower limit and the upper limit. If you needed to get the sample mean and you needed to get the margin of error is your, there's lots of ways to do it, but you can do your upper limit minus X bar. Standard error is not your margin of error. We won't even use that, I'm afraid. But the rest of it's pretty useful. They want the confidence interval. So we would enter in 3 decimal places, 0.361, nope, 362, careful there, for the lower, 1.0356 would go to 6. Fantastic. Does it appear there's too much mercury? Okay, the allowable limit is that it has to be below 1 part per million ppm. These are all in ppms. Now, only one of these was above, but the confidence interval for the population is from 0.362 down to 1.036. Are we totally confident that the mean for the population is below 1? No. We're pretty sure it's between these two. Therefore, we are not in the least bit confident that it is below 1. Does it appear there's too much mercury? No, because it's not possible the mean is greater than 1. Not true. Yes, because it is possible that the mean is not greater than 1. No, that's not what we said. They always put some in that don't make any sense. Yes, because it's possible that the mean is greater than 1. Yes. Also, at least one of the sample values exceeds 1. Yes. So at least some of the fish have too much mercury. Yes. What about the other? No. It's definitely not a no. So check it. Yes. Awesome. The last thing we want to look at is how to calculate a sample size. In this problem, it says an IQ test is designed so that the mean is 100, standard deviation is 17 for the population. Find the sample size necessary to estimate the mean IQ score. With 90% confidence, sample mean is within 4 IQ units of the true mean. Assume that sigma is 17 and determine the required sample size. Now, since we know sigma, we can use a z-score. We get the sample size by going to the same menu that we get the confidence interval from. So z-stats, one sample, it's z because we were given sigma, but this time go all the way down to width/sample size. We have to set the confidence level and the standard deviation. See where it says required parameters here? So the confidence interval was going to be 90. Standard deviation has to be sigma because this is a z. Now the width, if we want to make sure that we are within 4 IQ points, that means 4 above or 4 below. So the actual width is going to be 8. Just hit compute. Sample size is 49. Well done. Would it be reasonable to sample this number? Sure. We can come up with 49. So that should take care of most of the different kinds of problems that you can run into. If you find anything else, let me know and I'll throw together another video. And good luck.